Good afternoon. Welcome on to the webinar on safety of electric vehicles, organized by Rosefield Energy Tech. Rosefield Energy Tech, through Rosefield B2B, is a knowledge management platform for energy and electric vehicles. Through various service offerings like webinars, trainings, blogs, newsletters, and more, we are here to share knowledge about energy and electric vehicles. In fact, our mission is to make everyone, be it students or professionals, employable or entrepreneurial, through quality content, trainings on contemporary topics, and more. We have a strong support from HPCL. We also undertake various social media activities, and our LinkedIn group called the EV and Battery Club is getting good response. So I encourage everyone to join the LinkedIn group where we post daily original content. Electric vehicles market in India is poised for growth with various government incentives, increased drive range, and growing charging infrastructure. While electric vehicles have an inherent advantage in safety over the IC engine vehicles because of no conventional flammable fuels on board the vehicle. Without the combustion engine, the risk of fire and explosion from flammable liquid is eliminated. However, electric vehicles do run on lithium-ion batteries, which are flammable. The EV batteries are designed in such a way to be basically safe. With some news about safety incidents around electric vehicles, safety of EVs has become an important topic in the EV industry, and we all need to be aware of the various precautionary as well as corrective actions to be taken for electric vehicles. To do the same, we have eminent speakers from the EV industry: Samir Mishra, Chief Technology Officer, EV Group at JBM Auto, and Dr. Yashodhan Gokhale, VP Business Development, Octillion Power Systems. I would now like to invite the first speaker and take this opportunity to introduce him. Mr. Samir Kumar Mishra has got more than 27 years of industry experience and has previously worked with organizations like DRDO, Mahindra Reva, L&T, Schneider Electric, Sun Mobility, and Rockwell Automation. He has worked in R&D, engineering, manufacturing, and operations, greenfield projects with domain expertise in both LV and HV products across several industries that include 7+ years core expertise in the EV domain. Samir graduated from NIT Rourkela in Bachelor of Engineering, Electronics and Instrumentation. He has also done MS in Electrical Engineering from University of Texas, Dallas, USA. He also holds management qualification, Executive MBA with Outstanding Merit Medal from Indian Institute of Management. We welcome you, sir, to today's session.
Thank you.
I also invite our director, Schneider Gokhale, to have a conversation with the speaker, Samir Mishra. Welcome, Schneider, sir.
Okay, thanks, Kasturi. And I must say, what an impressive profile of Mr. Samir Mishra. And particularly, you know, when Kasturi was reading your profile, you also worked for Reva, Mahindra, and which was probably 10 years back. You know, they were far ahead of time.
Yeah, around 2009 and 10.
Yeah, so far ahead of the time. And of course, now EV has taken so much of momentum. So obviously, you know, on one side, we are all excited to see vehicles on the road. And obviously, it's going to help us to be, maybe when we look around, and particularly in a city like Delhi, where we are talking about pollution as of now, I think EVs on the road will be a good solution to that. But while people are going for EV or they want to buy EV, apart from range anxiety and battery life, I think the one major aspect which is coming now is on the safety. And Kasturi, of course, touched based on that how safety is going to be important for buyers, because it's always in consumers' mind, looking at various instances which have taken place in recent times about EV catching fire suddenly. There are some concerns about batteries. Then we have seen some videos somewhere from European cities where when they tried to charge the EV, suddenly the vehicle caught fire. So obviously people want to go for that. I think it's a necessity now for people to go for EV, and we are talking about so much of sustainability, and it's very, very important. But at the same time, I think it's very important to allay the apprehensions which are there in consumer mind about safety of EV. So I just wanted to have very informal conversation with you, Mr. Mishra, on the, getting to know about your views and advice on the safety. And definitely this conversation will help our viewers and listeners to know that EV is definitely a safe vehicle, though it's a different animal now in the automobile sector. I think already a lot of work has been done. And what is a better way of knowing about safety than to talk experts like you? So would like to have some of the questions now with you, and very informal. So since we are talking about safety, what do you think, what are the key safety measures adopted by EV industry in India?
Well, EV industry in India is just now going for a copy and paste kind of approach rather than having any creative approach. But having said that, if we'll take the globally, what are the measures which is being considered? So you have touched based that there are fires seen in Europe, and one Tesla vehicle which got busted in the garage itself. And the over the air software updated after that 4 vehicles in Tesla were in the risky measures, all those things. So there are so many news around the globe. So safety measures is not limited to India. So when having said that, all those things together, so I will break up it into the 2 levels. One is the system level electric vehicle, and as well as the component level of EV. So when I am talking about the in totality, the EV as a total system, it consists of battery, BMS, motor, controller, DC-DC converter, charger, and the drivetrain system. Correct? So when I am considering at the system level, so system level design is like the positioning of the battery in the vehicle, like what is the structural rigidity, what is the crumple zone, and what is the isolation mechanism inside the system from the EV perspective. What is the isolation mechanism that is connected from battery to the system? So, and how the battery is placed as a vibration proof, because this is all electronics parts. So vibration proof, what is the structural rigidity? So those are the considerations from system level, and this becomes critical, extremely critical right now. The approach which is changing from cell to module, module to pack, that approach is changing from cell to chassis approach. So cell to chassis approach means there will be no concept of module and pack. Direct on the chassis, the cells will be arranged, and that is extremely critical in terms of all those features I told, like structural rigidity, extensive crumple zone, and all those things. So there is a survey which is conducted right in by the Indian government, by some agencies, where the most of the collisions, and this is generic survey, nothing linked to specific to the electric vehicle, but the generic survey, what are the safety measures on the accidents? And most of these, the survey concludes that the rear end collision is the 40% part of the accidents. So rear end, this is a Government of India report, also in net one can search and find. This 40% is due to rear end collision. So that is what the key consideration or takeaway for electric vehicle design, because if you put the battery, most of the vehicles which is considering the battery to putting at the rear end towards the in the e-bus, you say if it will be there in the rear tire, behind the rear tire in that zone somewhere. In the some cars they are designing the rear. So rear end collision means that you can consider how critical it will be once something is hitting and the crumple zone is very weak and it will be piercing through the battery, and definitely there will be fire. So those are the learnings which has been taken further right now. People are, that's why, going for the cell to chassis, which is putting it at centrally. And also how nicely you will put it. If you will put at the back or at the front, so the battery being the heavy items in the electric vehicle, so the center of gravity will shift. So there will be, suppose there will be sudden brake or all those things, because these are such a delicate vehicle. People will love to accelerate because the reason is it's a battery and motor, it's electric. So the acceleration will be amazing. So with that thrill, someone puts a brake, and if the battery is not centrally placed, there will be a chance of toppling. So that will be measured. Once it topples and if it hits something pierce through the battery, it will be there. So that is another key aspects of the safety design which is being considered. So all those system level have been taken care of. Now coming back to the component level. Out of this component, I will consider two are the major. One is the battery and the BMS. Okay. Two are the most major things which lots of works are happening around it. So BMS is the, you can say, the father of battery is definitely the energy source. The BMS is the father of controlling the house completely. All safety parameters are in the hand of BMS. So if it is a case that the battery itself misbehaves, the BMS has the power to control it. Okay. Unless until the cell itself goes certain beyond limit and BMS cannot control, like the extremely low voltage case, and the cell has some short circuit where the BMS can sense only, but it cannot control the thermal runaway, battery fire, all those things. So having said that, when we are talking about the component level, a lots of test and validation and virtual simulations are being done right now. So gone are the years when the battery is just assembled and put it, but people are putting real time and lots of simulation approach in ensuring the safety of the vehicles and the battery and the BMS. And the BMS right now integrated with artificial intelligence, machine learning, all those things. So lots of features are there right now. So things are better. It is not so bad the way it was seen in 2016, 14, 15, 16. Right now it is improving. So having said that, there is a terminology in some article I saw a couple of days before. So in India, actually it is an advertisement by ARI, I believe. So if there is a EV safety, the way it is advertised, if there is a EV fire, call 156. Okay. So yeah, it's a very beautiful article. If there is a EV fire, call 156. So what is 156? It's a new regulatory standard by ARI, which is called AIS 156. It's extremely rigorous. So having said that, as I told a few minutes before, people have learned a lot from 2013-14, and they have migrated to a level in last 7 years that the standard which is coming as AIS 156, which is going to replace AIS 038 versus revision 2. That is for both battery and the electric vehicle is extremely rigor. And they have removed the nail penetration, which was a much buzz in the EV industry in India, that none of the cell is passing nail penetration test. So they have removed it. But having said that, instead of that, they have introduced the thermal propagation test, and which is exactly required to ensure the EV fires, once it happens, it will stay there. It will not propagate to the adjacent cells. Your design should meet that. So that is what the fantastic confidence our government agency is giving to all the EV consumers. And definitely, if that design is there, and we are working on it at JBM also, if that design is there, absolutely, if there is a fire also, but it will not be the massive outcome the way we are seeing right now. It will be controlled, and it will be staying there itself. And people have enough time to get out of the car, and there will be the dodging of fire, all those approaches, whatever in a normal fire we are doing right now, we can do that.
Yeah.
So that is that. So I will conclude my answer with this. So this is a very interesting thing I am going to give right now. So battery, like any other fuel, like the gasoline fuel, battery is considered as a fuel because it is powering the vehicle. It is considered as a fuel. And like gasoline, there are lots of restrictions. So when you are near the petrol pump, you should not switch on the matchbox. You should stay away all those things because the flashing point is very low. Sure. So when I compare, I am doing apple to apple comparison. When I am comparing battery with the gasoline, actually gasoline is more riskier than battery because the flash point is more. The flash point is very less. So, so it is more riskier. Only the battery will catch fire only when it exceeds certain temperature range. And once it catches fire, same thing in the gasoline, it will not stop so easily. Same thing is battery. So there is no difference in all
that's good to know, Mr. Mishra. And of course, we are going to get more insights about battery and BMS and safety related to that from Dr. Gokhale in the subsequent part of the webinar.
Yeah, so another just additional point, just one point on this, that I was going through a United States article that in National Transportation Society board. So they are declaring that people are raising hue and cry about the battery fire, all those things. But when they are not going through the actual outcome, that 170,000 vehicles, gasoline vehicles, go into fire each year.
Okay.
So 170,000. So how many, if you count from the day the EV has been introduced to the consumers, how many battery fires are there? Yeah. It will not cross more than 30 or 20 or 30. So, but the problem is, there is a strong lobby is working against it deliberately and persistently to discourage this introduction because the automotive industry will be at risk.
Yeah. Yeah. No, this is very interesting and very important statistics. In fact, I didn't know that there are so many cars, petrol cars, which are catching fire, 170,000. So you're absolutely right. You know, people don't talk about that, and they are talking about even one single EV. If they have caught fire for any reasons, you know, is obviously very, very important. And thanks a lot, Mr. Mishra, for sharing that. You talked about AI. So I was just keen to know that what is the importance of software and communication in electric vehicles so that which, you know, all these incidents don't occur easily and there is absolute safety for the vehicle.
Well, hardware and software are both wife and husband, you can say. So it's like the BMS, which is the normal hardware, electronics hardware.
Yeah.
So the software flashed on the BMS go hand in hand. So that is what the upper voltage and lower voltage limit, the charge discharge cycles, the DOD, then multi-level protections. All these are protection levels which are part of the hardware inbuilt into the BMS, and also the thermal management criteria. What is the criteria which is designed for the particular chemistry? That is also part of the software which is programmed. So ultimately, ultimately, when you consider the software as a part of the major things which is taking care of the safety in the vehicle, actually in last week when I was in the Economic Times webinar, so it's a very interesting point, which is exactly same around the safety of the vehicles came into the picture. So the whole team or the whole panel speaker got into a unanimous view that the software is taking a major stage, and it has been almost the 40% of the responsibility. 40% of the responsibility and role inside the electric vehicle is taken care with the software.
Oh, really?
Yeah, you will be surprised to hear that, and that is what exactly when I started digging out. You take the case of the machine learning, you take the case of artificial intelligence, you take the case of virtual simulations, you take the case of some additional redundant chip which is programmed into the BMS, which is having the fly-by action, on-the-fly actions for the diagnostic tools taking care of. So it is really playing a very important role. And of course, one interesting point I will definitely give here. So you are knowing the NMC cell 622 for this age-old cell. So NMC 622. Now then it got shifted to NMC 811. So the latest one is NMC 9.5.5, which is still to be commercialized, but that is very futuristic. So what is this feature which is from this second digit 2 to 1 to 0.5, a third digit 2 to 1 to 0.5 is coming? It is nothing but the percentage of cobalt in the NMC cell. The cobalt being the scarce and costly, and people, the OEMs and the cell manufacturers are smartly reducing the cobalt. And what is the role of the cobalt? The cobalt is doing a classic role of the specific capacity as well as thermal stability. So when I'm talking about the thermal stability, if you are reducing the cobalt percentage, so definitely your thermal stability will be at the risk. So that is what the role of the software. So maximum weightage of the cobalt, which is controlling the thermal stability, is taken care by the software. You can say that how much the cell manufacturers are leveraging the software at the cost of the material to be reduced. They are reducing the material cost, as well as they are implementing shifting that lever to the software control. So in that way, the advantage is the flexibility, reusability, lesser cost to develop, faster adoption, all those things when you will shift the lever to the software. So I will see this software which is getting programmed on the BMS as well as the cloud-based system in the back end, as well as the front-end edge computing systems for complex algorithm. This software will be taking much more prominence in coming time, because electric vehicle is nothing but a technology-sensitive product. It is nothing like sheet metal or plastic. It is a technology-sensitive product.
Yeah.
Absolutely.
Absolutely. And very, very important and very, very well you described, because, people like us really don't know that what is the role of software typically to ensure the safety of the vehicle. But sometimes I wonder is that, these are the things what you just described. How common people will know about that? Means, are there any conscious efforts being put by any of the OEMs in India where they will go proactively and communicate with people? Or what do you think, what could be their proactive strategies to ensure that people don't carry wrong impression about EV and safety aspect of that?
Yeah, actually, it is being said in the multiple forums, and it is being, the one good thing is there. When you are buying this is nothing to blame someone or finger pointing someone. but it is my observation, my personal observation. When someone is going to buy a vehicle, let it be the blue color person, or green color, white color person, or related to be the super executive. So whatever the level of vehicle they are buying, that the only question they are asking, what is the fuel consumption, all those things, and what are the basic fundamental like dashboard technology, all those things is happening in the gasoline vehicle. But when EV, if you will say EV, I think so far only the elite class is going and adopting the EV. Those who are having an idea about what is the battery, what is the motor, all those things, at least 5 questions they can ask to the dealer, and they can get convinced about, okay, something I know and something is here, which will be doing the same job for making a trip on the road. So that is what making the difference between the proactive strategy, whatever being talked so far in many seminars by government, in many platforms. The absorption of those knowledges are easy because it is elite class. That's why I came from that explanation, that what is the proactive strategy recommended for IB. So some of the proactive strategy which people know by doing some online research, or by talking to, or by hearing the seminars, like the lots of virtual simulation approach are there, which are addressing the design constraint and of the safety concerns. Like the 2 example which advertise heavily in the LinkedIn, like Lucid Motor Design USA. So if you go to the Lucid Motor Design website, Lucid Motor websites, so you will be surprised to hear 90% of the work they did in simulation. 90%.
90%. Oh.
90%. So the last 10%, actually that is the way, actually, as a R&D person, I am recommending like that only. Okay. So that is easy actually. 90% of their work they did in simulation, 10% they did the prototype, and in one shot, in first shot, they passed it. The reason is all those gimmicks, whatever they have played in the simulations, all those plus, minus, all those constraints they have addressed in the simulations. So similarly, another EV company, which is very fast rising EV company, which is VinFast. So it is in Vietnam. If somebody will go to the website, it's a very, very young company, 2017. And they have launched 6 new models in EV, and therefore they're strong foray into the USA market right now. So those are the bright examples. Why I took this example? There are multiple EV companies. Why I took these 2 examples? Because the virtual simulation dependency is so high, it has made them very successful. And all those safety protocols, everything they have virtually simulated, they have decided what will be the good. As I explained in my first questions, the crumple zone, the positioning, center of gravity, all those things they have taken care of. Okay. So having said that, in India also, I have been interacted with a couple of these simulations which we are using and proposing to use. So that is GT Suite, Gamma Technology. GT Suite is another simulation technology. Then COMSOL is quite good in EV domain right now. Okay. Mr. Binit Bansal, who is the CEO of the COMSOL, is a close friend of mine. So I know all those things are making news right now in this domain. So having said that, the another critical aspects which the proactive strategy part is coming is rigorous test and validation. Rigorous, yeah, this test and validation is a must. As I started my webinar on the copy and paste approach, that is fatal. All those news, whatever you are seeing, every alternate day you will find a new lithium-ion battery company is popping up. Yes, and they are thinking that it's very easy. You don't have to put your brain in the cell, all those things. Bring the cell, assemble it, put the nickel strip, assemble it, and somehow strap it and put it in the vehicle. And BMS is you can buy in $5, $6 from China, and it will work. But that is not the way. That is not the way. The reason is that will work in the cold countries where the temperature is not. This is the extreme climate condition in India. So matching to this climate, you should go through a rigorous test and validation, extreme low temperature to extreme high temperature. Low temperature is not a concern for us, but a high temperature is always a concern, which is a killer for the battery. So those testings are needed, as well as the continuous tracking of the cloud-based system. So this is what the confidence will be given to the as a proactive strategy to the consumers. The continuous cloud-based systems like per second data, how we will track and how we will control, and what is the proactive approach, like I told, artificial intelligence built into the system. Some strong diagnostic tool you will put in the part of BMS so that automatically either it will cut off the power in case of emerging situation, not to escalate the situation temperature, or if there is a fire, it will cut off the power from the battery so that it will be safe. So all those things, and on the supply chain side, there will be lots of care has to be taken on the connectors, because those are life of the battery pack overall, the connectors, the power connectors, all those things.
Absolutely. No, great, Mr. Mishra. And, I can clearly sense the passion which you have, not just for EV, but for the safety of EV. And I think you touch base various aspects in this conversation. Even you gave number of 156, yeah? That's the number which obviously we didn't know about that. So obviously there is a very serious response also coming from government, which is good to know about that. And I'm aware, obviously because of paucity of time, otherwise we would obviously go on, but I'm sure that viewers are going to put some good questions on that, and we have question and answer session later after Dr. Gokhale's session. But this is a great insightful session, Mr. Mishra, and really I enjoyed, and I'm sure that our viewers also would have got huge insights from your conversation. So sincere thanks for your time and this conversation.
Thank you.
And please stay back, because then we will have question and answers later. So I'm going back to Kasturi for you to introduce Dr. Gokhale. Yeah, and good to see you, Dr. Gokhale. So certainly Kasturi, of course, will introduce you. So,
thank you.
Thank you.
And thank you, Samir Mishra, sir, for this excellent insights in aspects of safety, aspects of electric vehicles. And thank you to Shailendra, sir, for this interactive conversation. I now welcome Dr. Yashodhan Pramod Gokhale for his presentation and take this opportunity to formally introduce him. Dr. Yashodhan Pramod Gokhale operates as Vice President of Business Development in Optilion Power Systems. He has vast 10+ years of research experience, both academic and professional, in Germany and India, in areas of energy, non-material, and lithium-ion batteries. His core strengths are development and process optimization of nano-based electrodes in order to formulate high-capacity anode and high-power NMC and LMO cathodes for lithium-ion batteries and gas diffusion electrodes, GDE, for lithium-air batteries. Dr. Yashodhan Gokhale has extensive hands-on technical experience in different research facilities such as Glowbox systems, power supply cyclers, experimental test fixtures, and analytical instruments, which are deployed by successful lithium battery labs. We welcome you, sir. Over to you.
Yeah. Thank you, Kasturi, Mr. Gokhale, for giving the opportunity to talk on the very important aspect, safety. Mr. Mishra ji has very well explained about safety parameters and what are the pros and cons. I just wanted to take some of the people from our school days, from periodic table, the material which is lithium, and going to talk about how the lithium-ion battery manufacturing there are challenges where the safety plays a very important role. So just I'm talking about lithium-ion battery, then how to make the module pack assembly, then critical parameters during the manufacturing, then key aspects. So in 2019, 3 young guys, I again say young because good enough 97, Stanley Whittingham, Akira Yoshino, age 70 plus, won the Nobel Prize for developing the lithium-ion batteries for the intercalation and development of LFP battery. That's a big breakthrough for the whole world. As we see the progress of lithium-ion battery is all about the cathode anode chemistry innovation. After the discovery of these materials, Sony come up with the new battery in 1990 to various platforms. Then A123 come up with the LFP battery, which is more sustainable. Then there are some change in the materials by the sodium ion, then lithium sulfur batteries, and people are exploring with lithium air or oxygen battery, but still it's in the development phase. And main purpose is to go from A to B, say 500 kilometers in a single charge for a prime focus in the automotive terms. This is just to give you an example, like 18650 earlier used by Tesla, developed from Panasonic, Samsung, LG, various companies, having anode, cathode, and separator, just to give the idea to the audience. Then prismatic cells made by Korean and Chinese OEM, where you can see the architecture, how it's built. Then pouch cell built by the Nissan Leaf vehicles, AESE, then LG and so on, and this is the construction. Normally in lithium-ion battery possesses by the phase formulation main on the anode side, anode material, then they use the different binders, then cathode materials, and then roll-to-roll machine. And all these mixture, when you make the anode and cathode, you assemble it, you test it by the various testing agencies from the electrochemical method, structural, and so on. I'm not going into a detail about the characteristic of these. And a very important thing is the cell that we have seen, whether it is 18650 pouch or prismatic. You can tap this cell level to form the modules, and the modules form a pack basically by putting the different wiring harnesses, then all other things. And one of the key concept is depends on your dimensions. With the series and parallel count of these cells, you can make the battery pack. In that thing, there is a structural aspect like mechanical safety, then protection from the thermal events, control system. And there are a lot of challenges in terms of the, while you are manufacturing, one is manufacturing challenges and other is the safety to achieve this battery pack in safer environment. This is like typical thing where the bus bars, this is one example like prismatic cells, which are do the welding. So if you miss any of the points, then there is a chances of the short circuit because these are the high voltage, high energy dense cells. So you have to always place the cells in a constant distance to ensure the cooling, overheating and so on. So this is just to give you an example, what is there in this black box called battery pack. If you see here, this is like one example where the cells and modules are kept, put it by the voltage sense, temperature sensors, surrounded by this cooling system, because temperature is the key parameter. Then it is connected by the wiring harness, then cooling manifolds, then pre-charge components and so on, to get the high voltage, low voltage connectors, then MSD and so on. So in this way, this battery pack is arranged. This is just to give you an idea what is there in the box, which is the highly dense, high voltage pack. Then this is what Mr. Mishra ji has mentioned. There is a fire in the car and how to avoid that. That you can see there are various ways, but you have to dial 156. That is the standard. You can check the reference in one of the news in Auto Economic Times recently. So why it happens? The question is lithium. As you see in the lithium ion battery, there is an electrolyte which is between anode and cathode. At high temperature, it gives a lithium loss, capacity fade. Then there is a lot of side reaction happening on the mechanical side because of the decrease in the anode surface. There is a continuous side reaction between anode to cathode. And during that process, there are many side reactions, which leads to capacity fade, power fade, and catches fire. Then lithium plating at low temperature, then the electrolyte loss. And all these things, when you design any battery pack from the cells, there are various ways to do, as console is one of the things he mentioned, but you can see GT suit and CFD, ANSYS can help you for prediction at different temperature, how your battery is going to perform. What's the critical point before, after that, there is a thermal issue. To prevent that thing, you do the simulation in a good way, as well as you do the practical. We do a lot in-house thermal tests where we can do the nail penetration and wire bond and so many things, so that we get to know the behavior of the cell at different temperatures. Then there is one aspect while designing these things, battery packs, the safety and comfort, these things you have to take care, because your battery pack go under the crash safety, then vibration test, then thermal runaway prevention, then cooling efficiencies, and so on. And how to do that in more effective way. There are different methods with the joining of these cells with the cylindrical, prismatic, and pouch. People use laser welding to avoid the lower internal resistance. Then these are some of the methods where you can find out the laser wire bonding is commonly used to achieve the good efficiency and less internal resistance in your battery pack. There are critical aspects where you can control the cell sorting machine while making the battery pack. Then you have to be very precise in handling these tools, because that can lead to, if you're doing the ultrasonic welding and joining these modules, cells to become the modules, then there is a possibility of short circuit. Then these sensors which are used to give you temperature, voltage sensing tools are very important. So there should be a precise handling machine. Then screwing with this high voltage, then there is a uniform charging at each level. And so it can lead to a very sophisticated way, sophisticated tools for screwing this technology, so that there should not be any thermal event on the cell level as well as for the module level. And all these things lead in a cycle, like as Mr. Mishra has mentioned, there is a lot of fire even in the IC engine that we rarely consider, as the lithium ion battery is a high energy source. There are few fires, and if you take care with the cooling system, we can maintain the temperature, we can avoid these thermal issues. And this is like a transition, evolution happened from IC to micro hybrid and so on to achieve the completely battery operated vehicles. And my company, we are making battery packs and BMS. That's our core competence. We have a localization in India. We have a robust design. We first time introduced the liquid cooling in India for NMC. In Pune, we have a complete laser. We also do the laser welding for the 21700 or 18650 cells. We do the liquid cooling for the bigger packs for commercial segment. So thank you for overall, and we can go ahead for the discussion. Thank you. Feel free to contact me.
Thank you so much, Dr. Gokhale. I'm sure all the viewers are now assured of the safety aspects mentioned maintained by battery manufacturers and thereby how safe the electric vehicles are. I'm sure there are a few more questions in minds of the audience. Before we go into the Q&A section, I'd like to mention we have a detailed course on electric vehicles on roadfieldb2b.com. So anyone interested to learn more about electric vehicles, do visit roadfieldb2b.com. I now invite our CEO, Bhaskaran Nagarajan, to moderate the Q&A session. And I again welcome both the speakers. I request all the participants to put in your questions in the Q&A section of Zoom. Please don't type out your questions only in the Q&A section so the moderator can pick up the question.
Thank you, Kasturi. Thank you, Dr. Gokhale and Mr. Mishra ji. This session was so excellent and very excited to know about the initiative by the government and then in RI specifically for safety related to the electric vehicle. And there are a few questions, and we have some of the questions received already through our Google Forms. So I just putting the first question is from Nikhil Vaidya. Considering the limitations regarding safety aspects of lithium battery in electric vehicle, what could be future alternative in battery? Possibly Dr. Gokhale can respond to that. Dr. Gokhale. Dr. Gokhale. Hello, Dr. Gokhale.
I think there's some technical issue.
Yeah, Mr. Mishra, can you take up this question?
Yeah, I'll take up it. See, yeah. If lithium is a constraint, the sodium ion, sodium air battery and lots of other chemistries are coming, solid state battery, all those things are coming also. So we are talking about the safety concerns at the temperature related to safety. So that has been already addressed. Actually, the research is going on to a level that you will operate from 0% SOC to 100% SOC at a given temperature, and the range and the scale, all those things will not be compromised, as well as you will get a very safe battery. You take the name of the company StoreDot, and StoreDot from Israel-based company, and they have developed a technology which on the fly the battery will correct itself any fault is detected. So in terms of the temperature, you are telling if there is a concern in the lithium-ion battery, that is being, it's not that you are buying a refrigerator has some problem and you will not repair it and use it. Similarly, this is another technology intensive product. So when you are buying a lithium-ion battery and the 40-degree temperature, of course, there is a solution to address that. Lots of cooling systems are available. So air cooling system, different kind of fin design for small batteries. Then liquid to air, air to liquid cooling systems are being matured also. Onboard cooling is there. Right now, the migration from the smaller medium vehicles, like during charging, the cooling system only works. So while the temperature rise, it addresses, suppresses the temperature. We have migrated to a level of having onboard cooling in certain cars and buses also. So during discharge also, if there is a 2C discharge or 3C discharge, onboard cooling will take care of it. As well as there will be a kind of sealing arrangements, the temperature sensitive sealing arrangements are there, which will encapsulate the battery pack, and inside temperature along with the cooling system will be intact. The environmental ambient will not impact the battery pack. So lots of solutions are there. So I am talking about if lithium battery with respect to temperature is a safety concern, it has been taken care of by all those alternatives. And if lithium-ion battery is not to be used because of the safety concern, there are alternative chemistries are also in the offing, which will be commercialized sometimes in 2022-23. It's a very, very near future, it will be commercialized. Lots of companies are working.
Thank you, Mr. Mishra. There is another question. It is related to, again, battery positioning. And I think Samir Mishra has spoken about much detailed about stability, center of all other elements related to the positioning of battery. Even collision you've spoken about. There is a question from Bharat Bhushan Bhagwat. Is related to two-wheeler. He's asking about two-wheeler EVs batteries are not fixed in position. Is mostly kept loose. The possibly is observation from the current available in the market. Will it affect the life or performance of the vehicle?
Yes, yes, surely it will affect the life of the vehicle because it can go under different vibration issues during, then there is a loose connect and all that parameters leads to performance on your battery life. Maybe you have seen recently a lot of news on batteries catching fire because sometimes they don't use the BMS to save the cost. Even the contactors are bad quality. It's not always about cheap. It should be a stable, sustainable battery that can, whether it is go in buses, trucks, or 2- and 3-wheelers.
Yeah, thank you. Mr. Mishra, while discussing with Shailendra, we were talking about the copy-paste format of current modelings are coming out in India. That is the reason for some of the challenges happening in India. So is there anything that can prevent or stop fire into the vehicles? Mr. Ji?
Yeah, see, the copy-paste is the problem of observing half knowledge, like bringing the cell, assembling, and some programming in the BMS. So when I'm telling the some programming in the BMS, so the major key factors are missing. See, I'll give you a very latest example, and it is no less than the Tesla. See, when Tesla has implemented the battery energy storage system with 35 megawatt storage system in Australia, and that too in 2020. And it recently in 2021, around March, after a year of operation, it caught fire. One of these 3 megawatt, the container caught fire. And the fire was spreading into the whole container engulfed. And the region, you will be surprised to hear the region they found out. The coolant leakage inside the battery pack, which got short-circuited, and it engulfed the whole battery pack. And that solution we knew in 2017 when I was working in the Sun Mobility. We knew that solution. The coolant, which is a 50% glycol, 50% your the distilled water, the coolant glycol, you will create a conducting path. So that is what the learning, which will be migrating and maturing slowly, and it will take time. So that is why I told the copy paste technologies, people are observing 50%, and 50% they are leaving it to the mercy of the God. That if it will click, it will fail. We'll see what will be done. So when I'm telling this, we have to be taken care of the operating parameters, which is a must. Operating parameter limits within the certain voltage, like your cell is designed from 2.5 volt to 4.2 volt. You should not go to gung-ho to juice as much as you can from 2.5 volt to 4.2. Yeah. You have to operate within 3 to 4 volts, something like that. Then there will be isolation failure. Then you should not, as Mr. Gokhale told, you should not charge it at a low temperature and extreme high temperature. Both have deteriorating effect. Then there will be much protection for water ingress. If water will be going inside, the moisture content, all those things, the live electronics, so it will easily short circuit. So those knowledge still lacking, and some companies which are matured a little bit and going into a 90% maturity, they are successful. But of course, this is not a constraint. It's a matter of time. Maybe by another 2 to 3 years, we will mature to that level.
And he has rightly mentioned, like half knowledge is really dangerous because
True.
you are handling the high voltage bomb. You have to
True.
care it handlefully. And India, the country where the temperature goes from 0 degree to 50 degree humid at the same day, different location.
Yeah.
So you have to treat it accordingly.
Yeah. I heard many times in many conversations something called battery assembling. Dr. Gokhale, can you exactly tell us what is exactly assembling of battery, which is confusing sometimes?
No, battery assembling is at the moment nobody is making cells in India. So there are two approaches. One is module assembly and pack assembly. From different cells, as I given in the presentation, smaller cells, you make a unit to form the module. Say 10 cells, I can make out of 10 cells, one module. And 10 modules, I can make one pack.
Okay.
So this is called assembly, where cells are coming from outside India, from our neighboring countries. Then you can do these cells by different welding techniques. Then you can put the BMS, the wiring harness, and so on. Make the assembly completely of the battery pack and deliver to the customer. So this cell only come from outside. The rest of the things you do it in-house, including
Okay.
BMS, hardware, software. That is called complete battery pack assembly.
Okay. So, Mr. You were talking about a lot of battery manufacturers are mushrooming in India. So exactly, is there any standard by RI or anything is already set in so as to track on them what they are exactly doing or how safe it is?
You are asking me or Mr.
You only, sir. You only, sir.
Okay. Oh, yeah. I mean, a very good question, actually. In fact, this is what we thrive on. This is what we stand on. So actually, there are a couple of standards which is by ARI, which is AIS 038 version 1, very old, 2015. Then that is for the electric vehicle. And then the battery standard is AIS 048. Okay, that is around 2017. So then the much rigorous version, like there are lots of hue and cry by all the manufacturers that you are introducing all rigorous standard, copying from European standard and American standard and putting all rigorous standard for India. So you have to get rid of the nail penetration, all those things. So then came the version of 038 version 2. AIS 038 version 2, which is revised, and they combine it for electric vehicle as well as battery. Right now, the toughest one, looking at the couple of fires, all those things. So the ARI has gone into a level up and they removed the nail penetration. They have introduced the thermal propagation test along with the vibration test, drop test, short circuit test, and all those capacity test, all those things. I mean, I think I have read the complete standard AIS 156, which is called, if in case of fire, call 156. It's really a standard which if people will be following rigorously while designing the electric vehicle and the battery, it will make a big success for India. And the path is clear with this standard if it is being rigorously followed.
Thank you, Mr. Mishra. Yes, doctor.
Yeah, it is very important in AIS 038 that we also do in-house nail penetration and other tests. Now, one of the important thing is if in the battery pack, if one cell catches fire, it's okay. But the neighboring cells remain as it is. That's the main purpose of thermal propagation test.
Yes.
At high energy cell, at 100% SOC is going to catch fire, but remain as it is, so it should not thermally propagate it. That is very well done by the testing agencies in India, which will be a really great help when the safety is concerned.
Doctor, one more question for you is from Ashutosh Shukla. Is the battery the only reason for fire in EV?
There are a lot of components which, because battery is the only source of energy. You can see in that way. If the battery is not working, your vehicle or any storage application is not functioning. But what happens often we have seen, rather than to trigger battery to have a thermal propagation issue, people use bad quality connectors. There is a coolant leakage or connectors, bus bars, which are not properly welded. You can save the money in choosing the bad quality connectors, wiring harness, which leads to a thermal issue.
There is a question from Middle East. Mr. Mishra, you can answer that. The nominal temperature at the Middle East region is normally 48 plus during the summer. In that case, what could be the successful thermal management from either decay or battery or risk of fire?
Yeah, so as I told very clearly, so we have migrated very quickly from air cooling to onboard liquid cooling. And this compact onboard liquid cooling is a craze now, and it is implemented in cars also. So onboard liquid cooling means the coolants, which I was in contact with one of the Malaysian company, which they have developed magnetic cooling also, which is a non-conductive cooling. And it will keep your battery pack around 27 to 28 degrees throughout. And if the temperature, the delta T, if through the discharge, if it rises up to 8 degree additional. So if it is going maximum from 28 maximum higher temperature to 36, no problem at all. It is a very good control over the lithium-ion battery for that temperature range. I can say up to 38 degree, 38, 39 degree, starting from 25 degree. That is manageable, and that technology is already available. So if you'll spend a little bit more, have an onboard cooling system which is already designed, it can work in the Middle East countries, it can work in the high temperature. The region I am telling you, it is barring the ambient conditions outside the environment, and there is a, as I told, there is an encapsulation already there, which is a thermal encapsulation, which is barring the ambient conditions to impact the battery pack inside. And if there is a only region which is battery temperature rise because of high discharge, that is taken care of by onboard cooling system.
Dr. Gokhale, there is a question related to the battery. Is the lithium-ion battery is the only possibility, or is there any other technology like phosphate battery technology is also being looked into for future?
No, the thing is that lithium-ion battery is a technology. Lithium iron phosphate, commonly called LFP, is a one type of cathode chemistry. Similarly, NMC, nickel, manganese, cobalt is a one type of chemistry, but it is under lithium-ion batteries only. You change the cathode material, you get a different energy density, different power. People are trying, if you look in periodic table, they tried with the sodium-ion battery, lithium-sulfur battery, aluminum-ion, and so on. And all this leads to an energy source. Every material has their specific energy density. Then people are trying with the solid state batteries. Still, there are challenges in manufacturing. Lithium air or lithium oxygen battery, where you take the oxygen and that energy density is enormous than the lithium ion. But there are different challenges, like you can tackle with the three-phase system where solid, liquid, and gas. So it's an evolution stage, and I'm sure there are some replacement, but not completely because of the stabilized process over the years.
Thank you, doctor. Just considering some paucity of time, I'll take two or three more questions. Next question is to Mr. Mishra. This is related to the swapping of battery. If the swapping system is introduced, the batteries are going to be kept in the vehicle that can be easily removed and replaced. So what kind of stability or something to be required to take care of it as a consumer while handling that kind of swapping of battery?
I mean, I'm confused with the question. Is it asking the small battery or is it asking the big battery?
I'm talking about the big batteries, swapping of batteries.
So big battery consumer has not to worry about it because it is a done. Suppose I will take the example. If I will take a specific example, it will be easy to answer. So I am taking the example of electric bus battery. So the electric bus battery, which is around 120 kg and it is around 120 kilowatt and it is around 700 kg. 700 kg, no consumer will handle personally to swap it. So it is automatically done by the robotic system or some material handling system which will be removing the battery and replacing back into the system. So the connection, disconnection, and the safety mechanism, all those things are installed in the charging stations, which is doing the swapping. If I will switch the question to the smaller battery, yes, there is swappable smaller batteries are there, and the swappable smaller batteries are very well designed for the universal swapping in either way. And that is actually the owner's pride. Actually, it's so much comfortable that you don't have to think and put brain how to put it, where to put it. Automatic glide system is there in the system, and the connector is there, universal connector is there. Either way you put, it will work. I think the swapping system which Sun Mobility has introduced back in 2017 has catch up fire like anything, and there are 5 companies, and of course the Gogoro has entered into the India, which is called the father of swapping technology. So it is going to be a revolution in swapping technology in the battery.
Yeah, and indeed, to add in the swapping, one of the key component is the connectors. How many times you are removing and putting the battery pack for two-wheeler, and that weight can be handled by the consumer basically. And so that connector is one of the key in the swapping of battery for two-wheeler.
Wow. With that, I just want to conclude. Prior to that, any safety tips from Dr. Gokhale and Ms. Mishra individually that will help as a consumer perspective?
As a consumer, the battery or vehicle that you are selecting, make sure which brand the battery is, because it's an energy source and you have to handle it carefully. You have to charge, discharge, though there is a auto switch off and everything is concerned. Like lead acid battery, there is no water. Every 6 months you have to put deionized water in the lithium ion. But you have to make sure which brand of the battery is actually going in your battery pack system.
Okay.
Yeah.
Okay. Your views?
From my side, it's only one tip I can give, which is very key, and this is from my experience actually. So for consumers, suppose in Indian system, suppose we are using mobile, we are having 60% charge. Well, let us charge it to make it 100%. Okay, there is a psychology actually. If you are free and if you are seeing a charger, put it in charger. Even though it is 60%, it will suffice another 5 hours. So that mentality is not good in the electric vehicle actually. Why? If you have certain charges and if the BMS is smart BMS is designed and taking care of, and it will cut off and it will give sufficient warning. And right now it might be a concern because you don't have charging station nearby, you will have an anxiety and you may do that. But having said that, in general, one should desist from doing this. Like if 50% charge, I am seeing a station and just pump it another 80%, all those things. So if battery will once charge go to a full cycle, the battery life will be maintained a lot. That is important. Yeah, that is second point. Second point, say related to that, suppose we are going on a long leave for 20 days, going for a holiday or going to in a vacation. Don't leave the battery pack in 100% SOC. Don't leave it on 100. It is a storage instructions that is again part of AIS 156 additional question, additional informations. You have to store your battery around 40 to 45%, maybe around 40% energy. And with the discharge of around 1 to 2% or 2 to 3% per day, you have to calculate how many days it will survive. So accordingly, you have to go for a leave. You should not put it. A fully SOC battery kept for a week or 10 days, it is risky.
Okay. Thank you, Dr. Gokhale and Samir Mishra, sir. With that, there are many questions, but I think you have answered so very clearly and without ambiguity of knowing what exactly safety requirement as well as vehicle management. With that, I request Kasturi to take over to continue the session to the next level.
Thank you, sir. Thank you, Bhaskaran sir, for moderating this session well, and thank you to both the speakers for answering the questions beautifully. There are a few more questions, so to the audience, we'll take these questions offline, and we'll try to send one mail the answers to these questions.
Yeah.
There is a feedback form link given in the chat box, so I request all the participants to give your feedbacks. Do let us know which other topics you'd like to learn more about in terms of electric vehicles or energy.
So thank you very much.
Yeah.
Thank you,
Thank
sir.
you.
We can stop the video.
Yeah.
Sure, sir.
Thank you. Thanks, Kasturi, and thanks,
Thank you,
team,
Dr.
for the
Yeah.
support. Thanks a lot.
Thank you, Dr. Gokhale and Dr. Samir Mishra, for this excellent session. I now, before going for the formal vote of thanks, I'd like to quickly, like I was mentioning previously, we have a detailed course on electric vehicles, beginners to advanced training program on electric vehicles. So these sessions are now available online with lifetime access on rosefieldb2b.com. So do visit rosefieldb2b.com and enroll into the course now. There are various video sessions, quizzes, assignments to hone your skills, and you'll be getting a certificate of completion on completing the course. So do visit rosefieldb2b.com and enroll into the course now. I now take this opportunity to give a formal vote of thanks. Thank you to both the speakers, Mrs. Samir Mishra and Dr. Yashodhan Gokhale, for this excellent insights into the safety aspects of electric vehicles. I'm sure now all the audience is much more assured and know what precautionary and corrective actions to take while using electric vehicles. I would like to also thank HPCL, who has always been a big support to Rosefield Energy Tech. Thank you to our director, Schneider Gokhale, for the interactive session, as well as our CEO, Bhaskaran Nagarajan, for moderating the Q&A session. Thank you to my team at Rosefield, Suhas Joshi sir, Bharat, Subhash, Prasad, and many others. So thank you. And of course, last but not the least, thank you to all the participants for joining in huge numbers. In case some of the participants have missed attending this session, we'll be sharing a recorded version for only the registered participants. So if you have registered and missed the session, you'll be getting an access, limited view access for the recorded webinar.
Thank you.
Once again, thank everyone for this wonderful session on safety of EVs. Thank you all for joining in. Have a nice day.
Thank you. Thank you.
Thank you, sir.